Hi guys, welcome back to Chemistry 24 into 7 series. From this series, we have been exploring the solution for previous year competitive exam papers such as CSIR, GATE, and etc. If you are new to the channel, don't forget to subscribe to see more engaging content like this. Let's see today's problem. So this is the problem based on LDA. So this is the question from CSIR 2015. According to this question, so this beta keto ester compound which converted into the corresponding keto compound. Here are the four options. We should find the correct options for this question. So for this, we should see one by one each reaction condition, what produced, and followed by suitable explanation. So this is the first reaction condition. The first condition which involves sodium methoxide and methyl iodide. When you take the beta keto ester compound, when you treat with sodium methoxide, so here sodium methoxide acts as a base, okay, which readily takes the proton from more acidic side. So when you look this ketone, so here acidic side as well as here also acidic side, since both sides are near to the carbonyl group. So particularly this site is more acidic since the site present in between two carbonyl group. Therefore, when you use sodium methoxide, which readily takes the proton from this side, which readily produce corresponding thermodynamically stable enolate ion. So after the formation of thermodynamically stable enolate, which readily react with methyl iodide by SN2 type of reaction, so which produce corresponding alkylated product. So next we see the another reaction condition is sodium chloride with DMSO and 160 degrees Celsius. When you subject under this reaction condition, which readily produce this corresponding ketone by the elimination of this ester unit. So exactly how it happened. So let's see magnetically this reaction in this slide. So here you see when you use sodium chloride, so which readily coordinate with sodium plus ions with carbonyl oxygen, so which produce this corresponding intermediate state or transition state. So in this medium Cl minus also available. So in usually Cl minus, I mean chloride ion is not good nucleophile to attack this methyl group. However, in the presence of wet DMSO, which readily attacks the methyl group through SN2 type of reaction, then followed by oxygen carbon bonds breaks, this electron move here, and followed by this carbon carbon bond also break, this electron move here, and this pi electron move towards to the oxygen atom, which results that elimination of methyl chloride as well as carbon dioxide, which produce this corresponding inlet ion when you do acid workup, which produce this corresponding ketone. In particularly, this type of reaction is called Karpacho decarboxylation reaction. So therefore, when you do Karpacho decarboxylation, which produce this corresponding ketone compound. The second reaction condition in A, which involves the LDA under minus 78 degrees Celsius and followed by the reaction of trimethyl silyl chloride. So first condition is LDA. So LDA we already discussed in our channel lot. If you missed to watch the LDA based our lecture, don't worry, I'll provide the link for this particular series. You can find from the description box whoever missed to watch our LDA series. So LDA is one of the non-nucleophilic sterically hindered base which readily takes the proton from less hindered side. So now you closely look this ketone compound. Here you see this site is sterically hindered. However, this site is less sterically hindered. Therefore, when you use LDA, which readily takes the proton, which produces this corresponding kinetically stable enolate ion. So after the formation of kinetically stable enolate ion, which readily react with trimethyl silyl chloride, which produce this corresponding silylenol ether compound. So the next step is the reaction of tertiary butyl chloride and titanium tetrachloride. When you use this reaction condition, so which readily produce this corresponding carbocation intermediate. So after the formation of the carbocation intermediate, so our silylenol ether which readily react with this carbocation intermediate. Here you see how this happens. So this electron comes here, then followed by this electron attacks the carbocation center, which readily produce this intermediate. So again, the Cl minus ion present in the reaction medium, so which readily attack the silicon atom, then followed by silicon oxygen bond breaks down. These electrons moves towards to the oxygen atom, which produce this corresponding ketone product. So based on this set of series of reaction conditions, it seems to be, so this first option would be a correct answer for this question. So however, we should see other reaction condition to solidify our better understanding about this kind of reaction. So this is the second reaction condition, which involves, just like our previous slide, sodium methoxide and methyl iodide. When you use sodium methoxide and followed by methyl iodide, which readily produce this corresponding alkylated product. The B reaction condition is aqueous sodium hydroxide, then HCl and heat. So when you use sodium hydroxide, which readily undergo ester hydrolysis, which produce corresponding carboxylate ion. When you use HCl, which readily produce corresponding carboxylic acid intermediate. After the formation of carboxylic acid intermediate, when you heat the reaction mixture, which readily undergo decarboxylation. Here you see how this happened. So this pi electron abstract the proton from this carboxylic acid group, then followed by this electron moves here and this carbon-carbon bond breaks. So which leads to kick off the carbon dioxide gas, which produce this corresponding ketone product. So the second reaction condition in A, which involves the triethylamine and trimethyl silyl chloride under room temperature. We should note the room temperature. Therefore, under room temperature, when you use triethylamine and followed by trimethyl silyl chloride, initially which produce thermodynamically stable enolate ion, which then react with trimethyl silyl chloride, which produce this corresponding product. So now you think about when you add tertiary butyl chloride and titanium tetrachloride condition, which probably undergo in this reaction this particular side rather than this side. Therefore, in this reaction conditions, I mean the sequence of reaction condition is not suitable to produce this corresponding ketone product. Therefore, we can easily omit this reaction condition. So next we moving on third reaction condition. The third reaction condition, which initially involves the LDA and followed by tertiary butyl chloride. So when you use LDA, which readily takes the protons from less scattered side, which produces corresponding enolate ion. So the next reaction condition is the reaction of tertiary butyl chloride. So in principle, these all enolate ions which readily undergo SN2 type of reaction. But tertiary butyl chloride is a SN1 electrophile. So therefore, this reaction may not proceed even if you try to use this enolate ion and tertiary butyl chloride, which readily undergo elimination type of reaction. For example, when you use this reaction condition, which produce this corresponding carbocation intermediate. So now this enolate ion acts as a base. In fact, this one is one of the strong base, which readily takes the proton from this carbon. So then followed by this electron, when it moves towards to this carbon atom, which leads to produce corresponding alkene product. Therefore, this reaction condition is not suitable for to get this corresponding expected product. So next is moving on, fourth reaction condition, which initially involved the karpacho decarboxylation reaction, which produce this corresponding ketone product. So in this ketone, when you treat sodium hydride and tertiary butyl chloride, this is exactly just a similar reaction condition, just like our third reaction conditions. So when you use sodium hydride, which readily produces enolate ion, once again this enolate ion is a best substrate for SN2 type of reaction, but this tertiary butyl chloride is a best substrate for SN1 type of reaction. Therefore, this reaction condition is not suitable to produce this corresponding ketone product. Therefore, based on our discussion, the first reaction condition is suitable for to produce this corresponding ketone product. Therefore, this is the correct answer for this question.